Welcome to LIB Academy, and in this video I'm going to take you through inverse Laplace problems and specifically shift theorem problems, which is the first shift. I have developed my own method, unique method that works a lot, and it saves you time. You can use 10 seconds or 20 seconds to solve problem, like as far as the inverse Laplace problem is involved. So at the end of this video, you will be able to analyze a problem, inverse Laplace problem, which involves shifting theorem. They are sometimes difficult to analyze, but I have an easy way to do that. So stay close with your pen and your book. Before we continue, I would like to tell you the connection between the elementary Laplace transform, standard Laplace transform formulas to the shifting ones. We have for the elementary one, e to the power at equal 1 over s minus a sine at equal a over s squared minus a squared. Same apply to the rest, right? But for the first shift theorem, wherever we see s, we replace it by s minus a. So let me give you a typical example. I want to show you where my shortcut trick is coming from, right? That is why I need to tell you all this. So let's look at sine 80 here, which is the basic one without shifting problem. You could see that we have a over s squared plus a squared. Now let's look at the same formula where we involve a shift problem. This is sine omega t, right? Instead of s squared, we open it up and replace it by s minus a all squared, right? So s squared here, where there is a shift, we open it up and replace s by s minus a all squared. Good. And if you are wondering about what the first shift theorem is about, I have a video on that. But for easy understanding sake, let me take you through. It means that we have two functions, an exponential function multiplying an algebra, or a sine function or a cos function. If it's a sine function, either sine h omega t or sine omega t, right? So if it is just omega t, then we have plus here, right? But if it is h omega t, we have minus here, right? Take all those things into consideration. Well, our interest is not this today. We are just going to look at inverse problem, but there is a need for us to know these things. So that's it. E to the power 80, either an algebra, a sine, a cos. That is it for the first shifting problems. These are the formulas we need to know. And if it is sine, either it is omega h omega t, then we have positive here, or sorry, h omega t, then we have a minus here, or omega t, and we have a plus here for the denominator. So now let me tell you where my trick is coming from. And like I told you earlier, you will not find it anywhere. I will see that inverse Laplace transform is dealing about converting a function of this form back to this form, right? So what I just need is where the problem is coming from. Is it a sine function? Is it a cos function? If it's a sine, is it sine h omega or sine omega, right? So now it means that looking at my denominator, I have a and omega there. It means that I can just compare the denominator of the problem with this general formula to find both a and omega. Very simple. So now let's go in. It is a basic math problem. Let's go into how my trick is coming from. Where my trick is coming from. Find the inverse Laplace transform of s minus 1 over s squared minus 2s plus 5. So now, looking at this problem is a shifting problem. Why? Because at the denominator side, we have s squared and an s term, right? So if it's a shift problem, is it a cos function or a sine function? If it is sine, is it sine h omega or what? We know for shift problems, e to the power at is something that is a must to be there. That is when we are talking about the first shift problem. So looking at this problem, I have a term s to the s minus 1 at the numerator side. This will tell me clearly that this is a cos function. But this is the case, I don't know whether it is cos h or sine h, right? I mean, is it a cos h or just, is it a cos h omega t or just cos omega t? Like I told you earlier, for shift problem, e to the power at is a must to be there. So now I can see there is a cos, because comparing this to that, you see that we have s. For cos, we have s minus a at the top, right? Cos. Now I don't know whether it's h or what. So there is omega t equal s minus if at the top is a must, and s minus a squared at the denominator side is a must. And I don't know whether this is a plus or minus, but at the end of the day, we will get to know. Just bring your omega squared. And one thing you should know is that the function that is given in this form, all the denominator were simplified, right? So, okay. The terms in the denominators at the denominator side were simplified. Since it's a must for me to have something like s minus a squared and something like this at the denominator side, this comes in my basic mathematics analysis. A could be 1, 2, 3, 4, 5. And trust me, no matter the value of A, either 1, positive 1, minus a negative 1, positive 2, negative 2, there is a clue. Let's look at that clue. I said a clue, right? A clue. If I have the term, since a term of this form is a must to be at the denominator side, s minus 1 squared, then if I'm to simplify this, what will I get? So square s, then 2 by s by minus 1, then I'll get minus 2s. I'm just expanding this bracket. Then lastly, I square 1 here, which will give me 1, right? I'll tell you the clue. If I have s plus 1 squared, what will I get? Square s squared, then multiply 2 by s by 1, giving me positive 2s. Squaring this will give me positive 1. If I have s minus 2 squared, what do I get? Square this, you get s squared, multiply 2 by s by minus 2, giving us 4s, and it is a minus. So plus 2 squared, which is 4. If I have s plus 2, you are wondering, why am I teaching this basic math? You get to know. Then square s is s, multiply 2 by s by 2 gives me positive 4s. Then squaring 2 gives me 4. Now, look at this. Look at the coefficient of s. The clue is coming from that place. Are you seeing something? So my interest is that just look at this term and you'll be able to convert it backwards to this form. If you are able to convert this term backwards to this form, then we are good to go. That is where my problem comes in, right? Before we deal about converting this backwards, assuming this one here was s minus 1 squared plus 5, right? So let's expand this. Expanding this one gives us, let's write it straightforward, s squared minus 2s plus 1 plus our 5 here, right? So at the end of the day, we are going to simplify this further, right? Which is s squared minus 2s plus 6. This means that the square here has an effect on the value that was here, right? Good. That is it. Just know that. I think this is the only way we can simplify our work, else we are going to do a lot of dirty analysis. So now let's deal about converting this back to this. So when you look at the coefficient of s and this, you could see that we have something like this. S, looking at the coefficient of s, this coefficient of s will tell you that is s minus, right? So minus what squared, and it was squared. Yes, this is the case. We are getting 2 here means that we have 2 by s by something to give you minus a 2s, right? And it's clear that this is a minus 1. This is a 1. This is 1. So when you're done, try simplifying it further. You see that you get the same thing. 2s squared. You square s, you multiply 2 by s by minus 1, giving you minus 2s plus 1, right? So that's it. So this whole thing, that's it. So let's think about converting this, converting s plus 1, converting this to this. So first of all, you look at this, you know that you have something like s, and is it a minus or plus? Look at the coefficient of s. The coefficient of s will give you that it is a plus squared, right? Multiply by what will give you 2s. Like if we are to simplify this, you square this, you get s squared. You multiply this by something to give you 2s, and it's 1, right? You could see that trying to expand it is just the same value, right? Right. So now, last thing, let's convert this. For this one, for this term here, let's convert it. So converting this, we have s minus 2s. We know that s term is a must here. Is it a minus or plus? The coefficient of s will give us that it is a minus, right? So minus squared. So what should we place here? Looking at this, you could see that 2 by s by something to give you minus 2, right? 2s, right? And this place is definitely minus 1, right? We are done converting this. We are done converting this. But this is the case that we have plus 5 here. And looking at this, when we simplify it at the end of the day, we got 6, right? Good. So let's say we don't know that 5. Let's replace it by omega. Now let's go back. Now you are able to do these conversions. Let's go back to the problem. Find the inverse Laplace transform of s minus 1 all over s squared minus 2s plus 5. Now, I don't want to suffer. That is why we already learned those stuff. Even if I will suffer, I should know where I'm going, right? Good. So the first thing to do is to look out where this problem is coming from. Where actually is this problem is coming from? Like what formula or what function are we talking about? First of all, you could see that there is a shift because at the denominator side we have s squared term and s term, right? Good. So there is a shift. And is it a sine function or a cos function? If it is a sine function, is it sine h or cos h or sine at? Is it a sine omega t or sine h omega t, right? And one thing generally, we know that once there is a shift, then we will have a term e to the power at. So what matters is for us today, is it a sine or cos? So looking at the general formulas, we have s minus something at the numerator side. So this is tell us that it is a cos function, right? But how do we know? Is it cos h omega t or cos omega t? We will get to find out, right? So now what we want to do is just write, since we found out that it is a cos function, we don't know whether it's h, but omega t is something that should be there. So it's s minus a all out of s minus a all squared plus or minus omega squared. After we are able to find the value for omega, you will know whether this place will be plus or minus, and whether this place is there h or not h. If this place is minus, then it means that we have h here. If it is positive, then it means that we don't have any h here, right? Good. So now, denominator analysis. Just write the denominator given in the problem. Then let's start analyzing it. So we have s squared minus 2s plus 5, right? Good. The reason why we were learning all those stuff was this. Like I told you, I personally tried to got those ideas and it works. With this one, you can use 10 seconds to find the inverse Laplace transform of shift theorem, which mostly we find it difficult to do so. So now we are trying to convert this square thing and minus 2s thing back to where it was coming from, because we know that for shift problems, a term s minus a squared at the denominator side is a must. So right, and we are dealing with the denominator right now. Good. So let's say s, and I'll tell you, is it a minus or plus? The coefficient of s will tell you that. So s squared, we know that will come from that. So minus, then we bring our square. Is it here? Are we going to write 2, 1, 5, 6, or 7? So you see this term came from 2 by s by something here. And 2 by s is 2s. By 1 here will give us minus 2s. By 2 here will give us 4s. By 3 here will give us 6s. So it means that this place will be 1. Right? Good. So now you can clearly see that our a here is 1. Is it a positive 1 or negative 1? If a was to be positive, then we will be getting plus here, right? Here, right? And mostly, like let's say if a was to be negative, then we'll be getting plus here, right? Good. And now that a is positive, the minus still maintains. So to get to know whether your a is plus or minus, just look at the coefficient of s. If it is positive, then a is minus. If it is minus, then a is positive. Opposite, right? Good. So now we know this. We know this now. So let's base on this only. Let's expand this only. So s minus 1 squared is going to give me square s, 2 by s by minus 1, giving you minus 2s. And squaring 1 will give you positive 1, right? Good. Now we want to find our w or our omega. So looking at the original thing here, it means that we have this term and a term that was added like this, right? To give us everything like this, and it was simplified to get this. So we know that the s minus a all squared term has one effect on that term that was here, right? Effect 1 that was here. So looking at this will tell us that this was actually 4. This 5 right here was actually 4. And it is not a minus 4. It is a plus 4. And addition 1 giving us 5. So that is the effect that this term right here, s minus a squared, has on this 5, right? So it means that our w was 4, right? If after calculation we are able to find this, and we expand this, and we get the constant that we get. If it is 2, it will have an effect on the constant that is at the original denominator given to us. Assuming this was 2, right? It means that 2 here, assuming this is 2 plus 2, right? It means that 2 was added to this term to give us 5. So this term will be actually 3, right? So actually. So actually, I don't know whether that really makes sense, right? You see, once you are able to get your a value and your omega value, you are good to go. And because we see that this one, only 1 was added to 4 to give us 5, and this is positive, it means that we are dealing with cos omega, no h involved, right? You see, you get it? Good. So now we know the value of our A to be what? 1. Positive 1. And the value of omega to be what? 4, right? And because it was simplified, that was omega squared, it was simplified, that is why it is 4. But actually it's 2. But omega squared is 4, right? I don't know whether this is making sense, right? But I hope you understood. I believe you are getting it. When we are done with our example 3 and 4 and 5, you get used to it. So that's it. Since our interest is to convert this a function of this form back to this form, that is what the inverse Laplace transform means, right? Then we now know it means that we just want to know A and our omega. Then we are good to go. Just substitute in. So it means that the inverse Laplace transform, for s minus 1 all over s squared minus 2s plus 5 is the same as, since we know that from this we gotten the value for A, we know that even looking at the numerator, it's even giving you the value for A. But how sure are you that there wasn't a term multiplying? Okay, inverse Laplace transform for s A over s minus 1 all squared and then plus 2 squared. So since it's the function of the form e to the power at cos w t or omega t, we are going to get the value for a is what? 1. So we just write t, and cos omega is what? 2. Then t. That's it for this problem. So you can just use 10 seconds doing this. Write your denominator in the question, analyze it, like try to convert it in this form. When you're done, expand this. When you expand this, the constant that you get, look at the constant that was in the problem. Then you know that this constant is having an effect on this, right? If this constant was minus, it means this one right here was 6, and then minus 1 giving you 5, right? Good. If it is plus, it means that this one here has increased by 1. Then it means this one was actually 4, right? And know that this value here was w squared. And whatever you get here is supposed to be the square of w. And to get it back, just try to find, like, turn it down. If you get 9, it means that it's 3 squared. 4 is 2 squared. Good. Find the inverse Laplace transform of 3 over 2s squared plus 8s plus 10. Well, now that you see that this one, it is a shift problem. We have s squared term and an s term at the denominator side. So now the coefficient of s squared is not 1. So always try to make the coefficient of s squared to be 1, right? So let's rewrite this problem. So I can see if I should factor 2 out, I can also factor this out, right? So 3 on 2. So factoring 2 out from the denominator, it means that the term that I'll get at the denominator, if I should multiply 2 throughout, I should be getting the same thing, right? So it means that since I factored 3 out, this will be 1, and the denominator side, this will be s squared, and this will be 4s plus 4s, and this will be 5 plus 5. Since I'm factoring 2 out, or it's just like dividing all the term by 2, so that 2 cancel out here, 2 cancel here, giving us 4, and 2 by here give us 5, right? So that's it. So now I'm doing denominator analysis. Okay. But before I do that, where is the problem coming from? Is it a sine function? Is it a cos function, or what? So I have to know that. One of my tricks, since we don't have any x term here, this is actually coming from sine, which is a sine function. But is it a sine omega, h omega or sine omega? Like as usual, like as far as it's a shift problem, the term e to the power at is a must, right? So it's a sign problem. But is it a sine omega, h omega, or only omega t? So I know that it should be omega all on s minus a squared plus, is it a plus or minus omega? I don't know. I'm here to find out. I'm here to find that out. Now, denominator analysis, right? So I'll have that the denominator to be 2, sorry, right? We simplified that one already. So to be s squared, oh, this is really getting bad. S squared plus 4s plus 5. And I want to turn this thing to this form because I know that for problems like this, the term s minus a at the denominator side is a must. So I'm turning it down. I'm turning it to this form, right? So I know that I'll have s. Is it a minus or plus? The coefficient of s will give me that. It's a plus, right? So square it. So how can I get this? I should have 2 here, right? Because this term actually came from 2 by s by something, giving me 4s. So 2 by s is 2s, by 2 is 4s, right? So that's, once I'm done with this, just leave it like that. What I will do is that expand this. The last thing I'll do is to expand this and now compare it to this, to the denominator, to the actual denominator, to the denominator here that was given. So now I'm going to expand s plus 2 squared. So s plus 2 squared is squaring s equal s squared, 2 by s by 2, giving me 4s, and then 2 squared giving me 4, right? Good. So now this constant here is going to have an effect on this 5 like we did earlier, right? So now that this constant here is positive and this one right here is positive, it means that this one actually, right, this term here, which is supposed to be our omega, has increased by 4. This one is telling us that positive 4 here is telling us that it has increased by 4. So in actual sense, this one's supposed to be 1, positive 1. And looking at that, is it 1 or positive? Because we also have the coefficient of this to be, this one is a plus, so it's positive 1. Is that clear? So this one is positive, so it was added to this, the value here, to give us 5. So this one originally, this is what? 1. Assuming this one was minus 4 and this one is 5, what does it mean? It means that this one was actually 9 and we deducted 4 from it, remaining 5, right? So assuming this term here was minus 2, it means that this 5 here was actually more than that, but we deducted minus 2 from it, right? Giving us 5. So it means that this one was actually 7. So now that this one is positive 4, it means that this one was actually not 5, right? It was actually not 5, right? Because we added 4 to it gives us 5. So this one was actually 1. Mind you, this is the easiest way to work out Laplace transforms, inverse Laplace transform. I think the rest will involve a lot of calculations. So now what is my W? 1. A positive or negative? Positive 1. We'll be dealing with negative problem, you get to know. So my omega or W is 1, but it's a positive 1. This is telling me that the inverse Laplace transform of 3 over 2, 1 over s squared plus 4s plus 5 is e to the power at sine omega t. Since my W is not negative, right? Right? If my W was negative, then this formula, we are dealing with a sine function, right? It will be like this, h, so that this side here will be negative. And don't forget that the value that we get is actually the square of w, and square of 1 is the same as 1, right? Good. So actually equal to the Laplace inverse of our w. We got it to be 1 over s plus 2, right? Plus 2 squared plus 1 squared. And don't forget that we had a constant, right? I can write the constant here, 3 on 2. So now, since it is an e to the power at sine omega t function, so I can just go ahead and substitute the values in. I know my a to be what? I know my a to be positive 2, right? My a to be plus 2, and my omega to be positive 1, right? Is my a actually positive 2? Because I intentionally was writing there. I know you might be also wondering, because from the general formula, this side should be minus a, right? And this time we are getting this place to be plus. It means that our a was negative. So minus, our a is minus 2. Remember, at the end of the day, what you get when you compare it to the general formula, you'll be okay. So it means that because we are having plus here, and this is where we get our value, the value for a, and here the value for omega, when you compare it to the general formula, then it means that our a is negative 2 and our omega is 1. So e to the power at, a is negative 2, bring your t, and sine omega, and omega is 1. I think generally there's no need to write 1 here, so just write t. So this is the solution for Laplace inverse of 3 over 2s squared plus 8s plus 10. So find the Laplace inverse of 5 over s squared plus 2s minus 3. Firstly, I have to know where the problem is coming from. And this is typically a sine function, because I'm not having a s term at the numerator side. That this is my only way of analyzing it out. And this one, there is a shift problem, because at the denominator side we have s squared and term and s term. So what do? I have to keep in mind, for the shift problem, a term like e to the power at, specifically the first shift problem, is a must. And I'll have sine either h or omega t. I don't know yet. I'm yet to find out. And the value for my omega will tell me that it's positive, then it's just omega t. If it is negative, then I'll have h, right? Yeah. So now this should be, since the sine function should be like s minus a to the power 2 is a must, and yet I don't know the value for my omega here. Can be a positive or minus. And mind you, this is not how to write the general formula. The general formula is like this for each term. I'm writing plus or minus here because I don't know whether the sine function, is it an h omega function or an omega function alone, because I'm here to find out, and at the end of the day I'll get to know depending on the value of w that I'll get. So after this, the next thing to do is to do denominator analysis, right? So the denominator is s squared plus 2s minus 3, and I'm trying to turn this back to a form of s minus e all squared. So I know that s, is it a minus or plus? The coefficient of s will tell me that it's plus, so plus, then squared, right? So here 2 by s by what will give me 2s. This term right here actually came from 2 by s by this. So 2 by s is 2s, right? And we're having 2s here. It means that by 1, 2 by s by 1 will give me 2s. So 1. Now that I'm able to figure this out, the next thing I'll do is to just take this one and simplify it. So s minus 1 all squared. Squaring s will give me s squared. 2 by s by this is plus, right? 2 by s by 1 to give me plus 2s. 1 squared to give me 1. So now, remember, we don't want to suffer, right? So when you are done simplifying this, just compare the constant that you get here to the constant from the original problem, right? Good. So it means that this one actually was minus 4 and you added 1 to it to get minus 3. So our omega is minus 4. That, remind you, that was our omega square value that they simplified to get minus 4, right? So our omega now is, our omega square now is minus 4. If you are wondering and you still want to form an equation to solve that, this one right here plus something to give you minus 3, right? So it means 1 plus x to give you minus 3, right? And you can solve for x. You will see that at the end of the day, your x is equal to minus 4, right? So it means the value for omega squared is minus 4. Because looking at this problem, they simplified everything up to the last part, right? And this one, the simplification all involve the term of s plus 1, right? So that's it. So now we know our omega value. Our omega squared value is minus 4, right? And our a from this side, we could see that this side is plus 1. So what's the value for our a? This side was supposed to be minus, right? And here we are getting plus. It means that our a2 is also minus, right? Good. So it means that the inverse Laplace transform for the problem right there for the problem right there, 5 over s squared plus 2s minus 3 equal, it should be proportional to the inverse Laplace transform of mean. What did you get our denominator to be? What's the denominator? Our denominator is s plus 1 squared. So s plus 1 squared, and our omega value is minus, omega square value is minus 4. So minus 4, we can write 4 as 2, right? Squared. So looking at this, comparing this to our general formula here, it means that we should have the value for omega here, right? To be 2, right? Because we know our omega is 2. A is what is from the bracket, which is 1. And omega here is what is here, right? So we should have 2 here. In this case, the constant wasn't clear for us to just factor it out, right? So now it means that we are having a fake denominator, a fake numerator here, and we are having a true numerator here. But what happened? It means something multiplied, so was multiplied by our true numerator to give us a fake denominator, and we don't know that thing. We can just figure it out, right? So that's where we are looking for a constant. You see this one, after the denominator analysis, we are now doing numerator analysis. This is the only way. So let's continue. I like forming equations. My true denominator, something was multiplied, or a constant was multiplied by my true denominator. That is why I'm not getting the same thing as this. Looking at our original problem, after we factored everything out, we got 1 here, right? But when we got here and we were comparing, like we got here and we see that here is 1, right? Good. And it matches with the value for omega as far as it is a sine function. You know, for sine function, we don't, yes, which matches with sine function. Because for this one, for sine function here, we got omega to be 1. So this is supposed to be omega, which is 1. And it matches with this numerator. Now, this is the case that we got omega here to be 2, and this one is 2. but this one doesn't matches with this one. So it means we have to do something. There was a constant. That is why we are not getting this, right? So something was multiplied by our numerator to give us a fake denominator. We don't know that thing. So we can say, let me write it here, 2y. So 2y gives me fake numerator, which is 5, right? So dividing through by 2, you could see that your y equal 5 on 2, right? So that was the constant involved here, 5 over 2, right? And it's true, if we multiply this thing by 5 over 2, you get 5 over this thing, right? Just that we didn't simplify this. So 2 can cancel 2 out. At the end of the day, we get our numerator here to be 5, right? So that's it. So now we are dealing with a sine function, and we've gotten the value for omega to be negative, and it means that it is a sine h omega, and it is a shift problem, right? So e to the power at sine h, these are the things that if you don't take care, you make a simple mistake. Either it is h or w, right? Omega, right? So now we can go ahead. We know that comparing this to the general formula here, A is 1, right? A is 1. But figuring out the value for our A, this place supposed to be minus, right? But we are getting positive. Yes, minus. We are getting positive. It means that our A was negative. So our A is negative, right? So and this side here is our omega value. Our omega is 2, right? Remember the negative sign we were getting there was to tell us that whether this side is negative or positive, right? Good. So omega is positive. So we can therefore go ahead and say e to the power at, and our a is minus or minus t sine h omega. Omega is 2t. So this is our final answer for a problem like this.